Genesis sequence.
My dear colleagues, time is running out. The Empire is intensifying its attack against our bases, and we are having great difficulty in rescuing the survivors. We must admit that we are struggling to organize ourselves, which is why the High Council of the Resistance is asking us to develop an information system that will allow us to assemble rescue fleets with the starships we have at our disposal. And I will explain you right now what is the main feature we have to develop here. So, assuming we have 5 survivors to rescue, our new products should search for the starships we have inside our inventory named Swappy. So Swappy is an existing web service which is developed in REST. It will take a particular look to their passengers' capacity, because we want to filter out the starships that cannot transport any passengers, such as here the X-Wing. Then to assemble a fleet, we'll apply a really complex algorithm based on AI. It means that it will have more than 3 ifs in the code. But to sum it up here, you can see that the Millennium Falcon has a 6 passengers capacity, which is enough for the rescue mission, so that will be the only ship in the rescue fleet. So time is running out, like I said, and we need to choose right now the architecture of the product we have to develop. And I'm proposing you to use this architecture, the classic anti-layered architecture. Who agree with me? Yeah, there's some people that didn't take a look at the title of the talk. Looks like so. Because it was a trap. Just to see if any Empire spy were hiding among our ranks. Because we won't use that architecture. Because this classic layered architecture, although it can be really helpful, it tends to age poorly with time and become hard to maintain. And I will explain you why. But first, I have just one simple question. In that kind of architecture, where are we supposed to find the business logic? Service layer? Yeah? So, yeah, service layer. But there's also one other answer. Everywhere. And it's true that with time you will find it everywhere. Why? Because this architecture has some kind of flaws. It doesn't properly isolate one layer from the other. So you will find some business logic in the controller and as well sometimes in the persistence layer in your data access objects. So it means that on that side it may be a bit hard to do some unit tests. Maybe you will need some integration tests or even a database if you want to test that business logic. And furthermore, if you move from one database technology to another one, it's pretty likely that you will have to recode the business logic included inside the persistence layer here. And even worse, the most wicked engineer of the Empire go as far as putting the business logic in the stored procedures. You know, directly in the database. Yeah, I can see people having here some post-traumatic stress disorder symptoms, so you know what I mean. But we don't have only this problem with the business logic. We also have problem with technical concern of the application. Because you might think that, okay, for the database concern, it should be in the persistence layer. But here we have cascading architecture somehow. So from the controller, you can see everything. So I'm pretty sure you have seen people doing some SQL requests from the controller itself, especially if you have seen any demonstration of the new Remix JavaScript framework. But usually, you can see also that kind of thing in the service layer. So here, I have taken one example, a random one on GitHub, which is the service layer of, I don't know what, but here, I have an exercise class that has been annotated with GPA annotations. So from the service layer here, we are shaping the database. And then you can also see that some of the fields here are annotated with Jackson annotations as well. So from the service layer, we are telling the controller how it should serialize that class. So here we are coupling together the controller and the persistence layer through the service layer. Furthermore, you will also see that here some fields are annotated with, if I can find that, here, joint column, or maybe you have also some joint table, if I'm not wrong. Here, no, it's there, so it's there. So it means that to value that field tags here, you will need a database or an integration test. I don't know why it is that slow that I cannot zoom out, but anyway, zoom in. So it means that once again, if you want to change here your database technology, you will have to change your service layer as well. It may have an impact on your controller, especially if you move to a NoSQL technology. So we have seen that everything is coupled. And we also have one other problem. Usually, we are using some kind of structuring framework, such as Spring Boot. But we tend to put that everywhere, even in places where it might not be the best choice. Why? Because if you are coupling your business logic with the framework, and you need to do an upgrade of that framework to a new version that has some breaking change, it's really likely that your business logic will no longer work and have functional regression. Although you didn't change anything about that business logic. So is that normal? I don't think so. And keep in mind that later, your backend will become legacy. Maybe 10 or 15 years ago, you have developed a Java backend using EGB2 or 3 because that was the main thing at that time. But now it's no longer supported, right? So if you have that kind of backend, maybe you want that to be upgraded to a new stack, such as Spring Boot and Quarkus, for example, or Quarkus. If you do so, it's really likely that you will have to recode everything, including the business logic, which is working fine in production, because that will be shaped for AGB only. And because all of those things, and the fact that this is a cascading architecture, if you have kind of compilation error in the persistence layer, the service layer will no longer compile as well as the controller. So here you can clearly see that, in fact, coupling means fragility in your application. So we need something that goes over all the problem I just showed you. And I will today do a demonstration of what is hexagonal architecture. So it has been coined by Alistair Cockburn in 2001. And you will see that this is a pattern for managing software complexity and technical depth. But we'll talk about that a bit later. So to explain what is hexagonal architecture, in hexagonal architecture, we want to sanctify the business logic, because this is the most important thing in your software. This is what is bringing value to your users. This is what is making money in production. It is actually what pays your salary. So you don't want that to be everywhere. So we'll take all this business logic and put it in a single place. That way it will be easier to write tests that has only one responsibility, testing the business logic, and nothing related to integration or technical concerns. And that place, we'll call that here the domain. So maybe now you have a question for me. Julian, what's the difference between that and the service layer we used to have? But that's quite obvious. The name. Now, in fact, there is a bit more. Because in the classic layered architecture, usually your service layer has two responsibilities, the business logic, but it has also to orchestrate deeper technical layers of your application, such as here, the persistence, or web clients, for example. But this is something we don't want in hexagonal architecture. We want the business logic to be agnostic from anything which is technical, to make sure it will last longer. So how do we do? Here there is a little trick. You see here the dependency on the right. We simply invert it. So it means that the deeper layers of technical layers of your application will depend on the domain and not the opposite. So you can put safely here the business logic in the domain that will be agnostic from the technical part. Everything technical will be outside of that domain, here in the controller of the persistence. So the domain, we call that the hexagon. I don't have time to explain you why, and the reason is not really clear, but anyway, Alistair loves hexagons. And outside, this is infrastructure. And with that, we have separated different concerns of the application. This is a better management of software complexity, because if you remember theory of software complexity, in the domain, we have what we call the essential complexity, which is the reason for being of your software, basically the business logic, right? What brings value. And outside, you have the mandatory complexity, which is all the technical parts that are required to make that business logic happen. And remember that if you mix all those things together, you are creating accidental complexity that some people call as well coupling or technical debt. So to understand how all those things are working, let's do a zoom inside this hexagon. So inside the domain here, the hexagon, I forgot to tell you something really important, sorry. In the domain here, there's no frameworks. The frameworks are outside. But because you want that business logic to last longer and to be able to change your framework without having to recode the business logic. But you're allowed to put here some libraries. You don't have to reinvent the wheel again. But do so only if the libraries you are using are not too invasive, and it should be quite easy to get rid of them without having to recode the domain. So limit your adherence surface to it. So to see how all the things are working, let's do a little zoom on the domain. And here you can see that there is two inner layers, the API and the SPI. The API here stands for Application Programming Interface, which is a set of interfaces that are the contracts of the features implemented by the domain. That will be used by the left side of the hexagon here, such as the controller. So this is for the outside to interact with the hexagon to retrieve the features. These interfaces here only depends on domain object. That way, nothing from the left side can contaminate the domain. So it means that all the REST resources will remain in the controller. You won't have any also Jackson annotation inside the domain. That will remain here. That will be easier if then you need to change that left side. For example, you want to move to RabbitMQ receiver. You just have to create a new component here that is using the same interface without having to recall the rest of the application. OK. On the other side, the domain needs to retrieve some data from the outside. For example, third-party services or from the database. So here we have the service providing interfaces, which are a set of interfaces defined by the domain to interact with the outside. The contract is defined by the domain. This contract depends only on domain objects. So that way, we won't have any contamination coming from the right side of the hexagon. So here we have a SQL client which implements the SPI here, but it has to comply with that contract, so it can only return here domain objects. So it means that in your domain, you will never have any GPA annotations, neither any entity manager and so on. That will remain inside the SQL client. So your domain won't be shaped like a SQL table. So it will be easier later if you need to change your persistence technology to, for example, a MongoDB. You just have to create here a MongoDB client implementing the SPI without having to record everything else. So this architecture is also called ports and adapters because the ports are the API and the SPI interfaces on which here the controller, the SQL clients can connect to adapt the outside world into the inner world of the domain. This is adapters outside. So enough talking. Here, we'll do a little live code to see how we can implement all the things. So here's IntelliJ. Let's say that we start from the really beginning. For now, we have nothing. And in Hexagonal Architecture, we usually start from the domain. Because first, we want to create the value. And then we'll deal with all the technical parts. So that's why for now, I only have one module, which is the domain. So here you can see in the POM XML file that I don't have any dependencies on Spring Boot, only on JUnit and AssertJ that I need for the test. In the domain, here, I have made the model of that domain. So I've represented what is a fleet, which is a record of starships. A starship is something that has a name and a capacity as an integer. Remember, the passenger capacity. So now we need to implement our first feature. But you have to know that Hexagonal Architecture is not only an architecture style. Now it is also a development process. And to shape the contract of the domain, we will do some acceptance test-driven development. So we will first write here a functional test. So what is doing this functional test? He wants to assemble a fleet for 1,050 passengers. Here, when we create that fleet, we'll have to make sure that each of the starships together inside that fleet have enough capacity for all the passengers we want to rescue, and that also each of the starships has capacity, meaning more than 0. Okay, so let's do some implementation now. So here I'm inside the functional test, so I need to call the domain. So I will define the contract to interact with the domain, and I would like this contract to look like assemble a fleet for passengers given the number of passengers. Assemble a fleet here does not exist, so let's create that as a local variable. I need to give here a type, so it will be the assemble a fleet type, okay. So here I will initiate that to null for now, and I need to create that type. Let's do that. So here, IntelliJ is asking me if I want a class or an interface. What should I use? Interface, yes, because I'm defining contract here. So I put that inside the production code, and in which inner layer of the domain should I put this interface? Sorry? But in which inner layer of the domain? API, SPI? API, yeah, you got it right. So if you don't like the name API here, you can use features instead if you want. So here I've created this interface, which is inside here the domain, as you can see. And now I need to populate the contract inside it. Okay, so here I would like to have this for passengers method, so let's create that. And what you can see here is that the contract only depends on object of the domain, because here fleets belongs to the domain, and also have dependencies on basic types of Java, which is totally okay. So it will prevent any contamination from the left side of the hexagon. Okay, so that part, I mean, we have defined the contract, but now we need a concrete implementation of that for the feature. So here I need to create that concrete implementation. I will call that fleet assembler. And I will create that as a class, because this is a concrete implementation inside the production code in the domain. And obviously it has to implement the contract I just have defined. So let's do so. For passengers. Here I have to put the business logic, so let's do so. Here you can see that the business logic is divided into two parts. Here, first, I need to retrieve the starships from the remote swappy inventory. Then here there is the AI, the one that should select the starships from the one that we retrieve from the swap inventory in order to make sure we can handle all the passengers here. And with that, we will be able to constitute our rescue fleet. So let's implement all the things. Okay, so here I'm supposed to retrieve the starship from the swap inventory. But remember what I said. Swappy is a web service. So to interact with that, I need to do some HTTP requests. But I cannot put it here, because HTTP is technical. So I don't want the domain to change if technical concerns are changing. If I move from Swappy to something else which is not HTTP, I don't want the domain to change. So here, I have no choice, but I have to create one abstraction of the outside. And I would like this abstraction to be named starships inventory with a method which is starships to retrieve all the starships. Okay, it doesn't exist yet, so let's create that as a field this time. Let's give here one type here, so it will be starships inventory. Let's remove that S, I don't like it. Okay. And it doesn't exist yet, so let's create that. Okay. So that time class or interface? Interface, obviously, because the concrete implementation of that will be a Swappy client that will be inside infrastructure, and I don't want to be coupled with the infrastructure here. So that interface, in which inner layer of the domain I will put that? SPI, you got it right. Okay. So it has been created here inside the domain, as you can see. Let's go back here to create the contract, so starships. And as you can see, it will depend on the starships of the domain to prevent any contamination from the right side this time. So I have to do a little trick here because I want to filter out the starship that doesn't have capacity, but it's not really important. I know that you are all waiting for the implementation of these select starships, right? This AI. Be amazed. You are not prepared for that. Okay. So I lied. There is no 3 if, so this is not an AI. But yeah, I mean, here it's quite naive. It's just taking one ship after the other until I have enough ship to transport everyone. But it's not the main point of the talk, right? But here, the business logic should be implemented. But to make that work, I need an instance of Starship inventory. So basically, because it will be implemented by the infrastructure, I will do some dependency injection through the constructor. Oh, IntelliJ said that I have one related problem. Yeah, this is because I need an instance of this Starship inventory in the test. You have to understand that inside the test of the domain, we cannot have any coupling with technical parts as well, because we want the test and the domain to be standalone. So here, I have no other choice than doing a stub. So I will create here a referential. I will inline it with fake data. I have several ships having different capacities. And I simply have to pass that here as a lambda to the fleet assembler. So, and this is totally OK. It's fake data, but here we want to test the business logic only. We don't care about integration. We'll do integration later. OK, so let's run the test now. So the test is there. Hope it will work. Crossing fingers. Yeah, it's working. You can see the content here of the fleet. So what we have seen so far, we have created a functional test to shape here the domain. With that, you have to understand that, in fact, this functional test takes the place of a controller, for example. So it interacts with the domain through the API we have defined, which is assemble a fleet there. It only depends on the fleet and starship domain objects, and it has been implemented by the fleet assembler here. That fleet assembler implementation, it needs data from outside. Because we cannot depend directly on the infrastructure, we created here an abstraction in the SPI, which is Starship Inventory, that only depends on the Starship here from the domain. And because I want to test that business logic, I need to create a stub here that implements that contract. OK. So the next step here in hexagonal architecture is called opening on the left. It means that now we have created the logic. We would like to make sure it actually brings the value it's supposed to. So we'll export that value, this business logic on the network using here a controller. OK, so let's go back to the code and do some live code here. So let's do a little fast forward because there is a bit of boilerplate. OK, I'm coding so fast. So here, now I have one infrastructure module. And this is where I will put the controller. You will see that this infrastructure module depends on Spring Boot. Makes sense, because a framework is made to handle mandatory complexities. So this is the right place. In order to secure the domain and to make sure it will be isolated, I also added here the Maven Enforcer plugin with the ban dependency rules. That way, if by mistake here I'm adding something which is forbidden, like, for example, the infrastructure, the build will fail. I have put here a wildcard, but don't do that. Do some fine-tuning, so just for the live code here. If you don't like multi-Maven module project, you can use instead for domain infrastructure packages and perform exactly the same kind of checks regarding if it depends one from the other using ArcUnit that you may know, which is a testing library. OK, so now let's implement our controller. But first, I will do some integration test development. We'll start from the controller test. That way, I will be able to shape the REST API. You can see here, I'm expecting to be able to do a post on the rescue fleet endpoint that should accept a JSON, in which I should be able to put a number of passengers. For the test here, I'm setting it to 5. And as a response, I would like to get a status created, so meaning 201 in the HTTP. So it means that I should be able to create the rescue fleet resource. And inside this rescue fleet, I should have here an ID, a list of starships. And for that test, I should have only one starship. That should be the Millennium Falcon with a 6 value for the capacity. Okay, so now let's implement that controller. So basically, this is here that I need to implement what is missing in the post mapping here of that endpoint. So basically, from the controller, I just need to call the domain. So I will reuse here the assemble a fleet contract. Okay, so number of passengers, I will retrieve that from the rescue fleet request serialized by string, because this is a request body, as you can see, it's there. Okay, so I simply have to get the rescue fleet request there and get the number of passengers from that. So assemble a fleet does not exist, so I have to create that as a field. And here it's asking me if I want to use fleet assembler or assemble a fleet. So if you don't like having too many interfaces on that side only, you can use the concrete implementation if you want. But personally, I also like to rely on the contract, so the interface, because that way I will be able to stub the domain inside the controller for the test without having to rely on external testing frameworks such as Mockito, for example. But do as you wish. Okay, so here you can see that it does not compile because the domain returns a fleet, while the endpoint wants us to return a response entity of that fleet. So response entity is an abstraction made by Spring to represent an HTTP response. You can put inside it headers, the payloads, and so on. So definitely it's something that we don't want inside the domain, right? Because if you move to Quarkus, you don't want to change the domain as well. So basically, this is a responsibility of the controller to do the adaptation from the fleet into a response entity of that fleet. So let's do some wrapping there. Okay, we have the fleet, and we'll wrap that into the response entity of the fleet by using simply some Spring Boot factories created here to respond with a 201, and I'm passing the fleet here as the body. But it won't still work because I need an instance of assemble a fleet. So I would like Spring to give me that through dependency injection. But as you can see, it won't work because IntelliJ says that there's no bin of assemble a fleet in the Spring context. So what do we do in that case? Sorry? Yeah, I heard the annotations, right? This is true. So what we can do here, we can go inside the fleet assembler and add component or add service. Is that a problem? Yeah, because they come from the Spring frameworks, right? So we cannot do that here because we don't want the domain to be coupled with Spring. So what does people do in that case? They go inside the domain, the infrastructure, they create a configuration, and usually they do some bin factories, like that. Some bin factories. With add bin here, they will instantiate all the objects of the domain. But I don't like this option neither, because it's like doing half of the job of the dependency injection framework. I rather like to rely on the annotations because it's a better developer experience for me. And there is a little trick that can make sure that it's not the domain that knows Spring, but Spring that could be aware about the domain. And this is really easy to do. In fact, inside the domain here, I have created my own annotations. For example, domain service. If you don't know what is it, it comes from domain-driven design. It represents a feature if you want. And I simply have to annotate in the domain my fleet assembler here with that domain service. So that way, here, you can see that since it has been there is a retention policy set to runtime, Spring will be able to discover this annotation during runtime. But still, we have to make sure he's aware about this annotation, right? And you'll see it's quite simple to do. In one configuration, you just have to add a component scan directive like that. So here I'm telling Spring to scan my custom annotation. And now, if I'm going back to the controller, you will see that here, I no longer have any problems, and even TJ will see that this is the fleet assembler that will be injected in the controller. So this is pretty neat if you don't want to couple your domain with Spring. But still, I need an instance of the Starship inventory. So here you have two choices, two options. First, you can implement the Swappy client. Or you can do what I will do. Here, I will simply stub the Starship inventory, and then I will explain you why I'm doing that. So to have a Starship inventory stub, I can simply reuse the one I've done inside the test of the domain, remember? So it should be there, here. And I have just wrapped the referential into a new class, which is Starship inventory stub. As you can see here, this is the referential I used to have. And obviously, the Starship inventory stub implements the Starship inventory contract. So the thing is that Starship inventory stub is inside the domain and in the production code. This is quite weird, but I will explain you why just after that. So here, to make sure Spring is aware about, can scan this Starship inventory stub, I can simply here put another custom annotation, which is, stub, like that. Okay, it has been defined here. And I simply have to extend here the component scan that says that you should also scan for that stub annotation. And now, if I'm executing the controller tests, it should work. Let's see that. Yeah, a lot of warnings, but it's working. We don't care about the warnings. The test is green. So why did I stub here the Starship inventory? Because with that, you are able to be a bit more iterative in your development process. This is a technique I used while working at Expedia. At that time, we were working on a rail booking system, which was really in a bad shape, and we had to recode it from scratch. Unfortunately, the mobile teams already had planned to integrate that backend. So we made a deal with them. We said, OK, we will deliver you the business logic, and you will be able to use that because we'll code also a controller. But you will have fake data. But the thing is that this application, you can run that in pre-production if you want. And this is usable. So for example, it has been started here. I have prepared a request. I will do a post on Rescue Fleets. And if I'm executing that, this is working, right? So even if this is fake data, the business logic is true. So that way they were able to start their development, to start understanding the domain and make us some feedback without having to wait for us to code the rest of the application. And the right side of our new application, meaning the client to interact with the inventory of the trains, was so complex to do that it took us more than a month for the full team to implement. So they didn't have to wait for that. So we had feedbacks, and we were able to parallelize the work. OK, so what we have seen so far. We created an integration test to shape our controller that is using the domain through here the API assemble a fleet, exactly like the functional tests. And to make sure that we are able to deploy that thing just for some, let's say, beta testers for consumers, we put a stub inside the domain. But we won't be able to last long on that fake data, right? So then we need to create our real Swappy client. But first, I need to show you what is Swappy. So Swappy is an existing API. You can all use that on swappy.dev here. It's basically inventory of planets, spaceships, vehicles from the Star Wars universe. And I'm more particularly interested in the starships here endpoints. I will use that like it was my external Starship inventory, Swap inventory. OK, so let's integrate that in our product. So, Okay, it's there. Oh, it doesn't want to slide. Okay. So here I have prepared a bit the thing because you can see that now it's magic. I have a Swappy package in which I will put the Swappy client. But first, what I will do, a test. Yeah, you have it. So here I have the test of my Swappy client. And then when I will call starships on that Swappy client, I would like it to return a list of starships here. But since Swappy is an external system, I don't want my CI/CD to be unstable because of that. So that's why here I've configured a mock server. I think you know what is it. It just simply simulates Swappy inside the test. So it's expecting here to retrieve a get on the starship's endpoint, and it should return with success here that Swappy response, which is a JSON. And I will show you what is a Swappy response, because I've made an abstraction of the Swappy API. So the thing you can notice here is that Swappy is paginated. Oh, interesting. I don't want my domain to be paginated, right? I know that I will never return a lot of data. So we'll have to deal with it in a way. You can also see that their endpoints are kind of generic because the starships here are named results. I don't like it. And also there is a lot of data here, but I only need the name and the capacity, which is named here passengers. But also, their passengers are a string. Okay, it's not convenient for me because I would like to sum the passengers value, right? So let's see how we'll deal with that. So the Swappy client, obviously, you can annotate that with @component from string because this is inside infrastructure. So you can have a separate module if you want for the Swappy client. Here, to simplify, I have put everything inside one infrastructure module. So obviously, it has to implement the Starship inventory contract from the domain. So basically, this is the Starship's method we have to implement here. So we'll put the interaction with the real Swappy server there. There is something interesting here because the domain wants to retrieve all the Starship all at once. But Swappy is paginated. Thanks to the fact that we are inside Hexagonal Architecture, we won't be contaminated with that concern because this is a choice from Swappy, so it will remain in the Swappy client. Usually when you have a service layer that depends directly on your web clients, when that web clients become paginated, sometimes your service layer becomes paginated as well. But here we have a good isolation, so it will never occur. So we have to deal with pagination there. So here we are initiating the first page to the first endpoint, starships, and until that page is null, we will retrieve the starships from Swappy on that URL, and then we will convert the Swappy response into the starships of the domain. I will explain a bit later why. After that, we iterate to the next page. Okay. So retrieving the starships from Swappy is quite easy to do. As you can imagine, this is a simple REST template doing a get on that URL, and I will serialize the response into a Swappy response here. A Swappy response is something which is defined in the model of the Swappy package here. And you can see that I have a next, which is the next page, as a string, and results, which is a list of Swappy starships. I didn't map the other fields because I don't need them. So what is a Swappy starships? It's something that has a name as a string and a passengers as a string. Not convenient. In the domain for a starship, remember, we have name and capacity as an integer because we want to sum these capacities. So basically what we need to do here is a mapping, is an adaptation. That's why this is called adapters in Hexagonal Architecture. So that's why here in that conversion, I will have to simply do this. So I will stream all the results of the Swappy response, which are Swappy starships. And I will create a starship from the domain from this Swappy starship using their name, and passengers that will be passed as an integer. What is really interesting here is that, in fact, once again, having passengers as a string is something related to Swappy implementation. And my domain doesn't care about that. Furthermore, if then I move from swappy to another inventory that is using, for example, big decimal, I don't want my domain to change. So that's why this is here the role of this client to do the adaptation. So now it should work, right? So let's go inside the swappy client tests and let's see if it works. Okay, go home. Oh, warnings, but that time it's fading. Okay, why? Oh, sometimes we have NA as a passenger's value. Okay, so let's see the JSON I have extracted from swappy should be there. And yeah, sometimes we have NA. Okay, interesting. And also, sometimes I have unknown. Okay, so it seems that the data consistency of swappy is really bad. But this is also something I don't want to be indulged inside the domain, so I will show you what we should do about it. But also, if I'm moving to the next page of swappy, sometimes we have 1,000 separators. Okay, so looks like swappy is more made for front-end than a back-end, right? So perhaps it was not the best choice to use that as an external inventory. But anyway, we have to deal with it. So in fact, having unknown and NA for passengers value is, let's say, perhaps a mistake of swappy, or I don't know, but I don't care about it. The domain needs real data. So it means that this is the aim, I mean the role of my swappy here clients to filter out these starships, because I cannot do anything about that. So here I want starship that has only valid passengers value. And how you do that? Simply by get rid of everything that is NA unknown. And this is something that you should never put inside your domain, because this is accidental complexity. If you put that in the domain, you will have every time to do some defensive code that may disappear if you move from swappy to another better inventory. Still, I have to deal with the 1,000 separator, remember? My master gave me a really good trick without having to deal with complex number formatters and so on. Simply do some replace all, comma, here, empty strings. So maybe you know that my master is ChatGPT. Don't use that in production. I'm allowed because I'm a prompt engineer. You don't. Okay, so let's restart the swappy client test. And yeah, that time is working. So it means that now I can restart the application, put that in production. Okay, it's starting. I can reuse here the request, and I should have response from swappy. So you can see it's a bit longer, but it should come. Okay, please. Okay, yeah, I have it. There is many more starships here, so clearly I'm no longer relying on my stub. So we have created an integration test to shape our swappy client, which has to comply with the starship inventory contract. So it means that it has to return starships the way the domain has defined them, with an integer for the capacity. Since swappy has made really weird choices, I have to represent what is a swappy starship with the passengers as a string. And this is the aim of that swappy client, to do the adaptation. But it also do what we call an anti-corruption layer, because it also remove all the starship that has an NA or unknown value that the domain cannot handle, because everything inside the domain should be always consistent. Okay, so let's say we have put that in production. It's working well. But we had to add a new feature. We need to take into account the cargo capacity of these starships, because our survivors, usually they have materials, and we want to make sure they can get the materials with them. So here, okay, it doesn't. Dell is doing some great stuff now, okay. So here you can see that inside the domain, I've made a little modification in the starship here. No, okay, it doesn't work. Okay, okay, it's there. Now I have a cargo capacity. It's annoying me because next to that I have a capacity. This is a bit, let's say, confusing. I will do some refactoring here. I will call that passengers capacity. It's better. Okay, yeah, let's do the refactor. Maybe you're wondering why I'm doing simple refactoring at the end of the talk. So what's the impact of what I have done here? Do you have any idea? No? Sorry? On the domain, this is the domain, but what's the impact? I just broke the consumers of the REST API. How could that be possible? I can show you that simply by restarting here the test of the controller. Okay. And you can see that it no longer passed. Why? Because here the test is expecting me to return a capacity inside the Starship JSON, while now I have a passenger's capacity, as you can see here. And why? Because if you go to the rescue fleet controller, I'm directly serializing the fleet from the domain. And this is a common mistake, because at no time I have represented what is a REST resource. And because of that, my consumer is coupled with the implementation of the domain. If I've changed the domain, I'm breaking the consumers. So it means also that I have to do some REST deprecation inside the domain and some REST versioning there. A nightmare. So it means that to fix that, it's quite simple what we have to do. We have to create, for example, here, a fleet resource, which is a representation near the controller here in the infrastructure of what is the REST resource. That way, it will be easier to handle some REST deprecation, because simply here, I'm saying that a Starship resource inside the fleet resource has a capacity for backward compatibility. And here, I have the new field passengers capacity. And I have also a map of I don't know why it doesn't want to slide on the right, but I have a map that has all the deprecation information, so I can put that here in the resource. And you can see here, I simply have to map twice the passenger's capacity of the domain without having to change the domain itself. So that way, I have a better decoupling between the consumers and my domain because I have represented what is a REST resource. So it's really important to do so because these resources are, in fact, a kind of anti-corruption layer to the domain. So it will decouple your consumers from the implementation of your domain. And we'll avoid to have some REST deprecation in the domain or versioning there. So if you want the big picture of Hexagonal Architecture, this is all what we have done. I don't have time to show you here this, oh, maybe we have time. Okay, so I have an integration test that tests all the things together, but basically this is just a Spring Boot test, and I have here my mock server using that will mock the Swappy server that makes sure that everything is working all together. But anyway, I don't think it's really important to see that, but you have, if you want to learn more, you can scan that QR code in which you will find the repository, the slides, and also some other article I wrote on Hexagonal Architecture, including a deep dive implementation in Spring Boot and Java or Kotlin, I don't remember. So my name is Julien Topsier. I'm a technical coach at Shadow, which is a consulting company. And if you have any question, don't hesitate. Thank you very much. So I think we have time for one question. Yes?
Just a question. Are there any cases or any systems where you say that hexagonal architecture is not a good choice?
Sorry, I cannot hear you.
Is it any case that you say this architecture is not a good choice?
When hexagonal architecture is not a good choice. Okay, so the counterpart of the hexagonal architecture, as you have seen, is that you are doing a lot of mappings. Because in the domain, you have one representation. In the controller, you have one representation. In the database, one representation. If you have a third party, you have also one representation. So hexagonal architecture is great when you have strong business logic, a lot of them. If you have a simple CRUD, I may not use that because now you have things like, for example, Spring Data REST. That can be a great thing if you just want to have a CRUD over the database. So I won't use hexagonal architecture on that part. and especially if you don't really care about, let's say, be able to change technology. Because this is one of the main things of the hexagonal architecture, changing one adapter to another implementation. So yeah, nothing is a silver bullet anyway. So thank you very much. If you have any more questions, you can see me here. Thank you. Hey.
All systems are nominal. Initialize Genesis sequence.